Okay, so for all you AI buffs out there, let's dive into something that's been on my mind. We hear a lot about hardware, right? And how GPUs are the thing for AI. But what if, and stick with me here, what if the next big leap isn't about cramming in more parallelism? What if it's about, well, less?
It really makes you think, doesn't it? We're so used to scaling up, meaning more and more parallel processing. But is that the only way forward?
Exactly. And that's what caught my eye about this Reddit post. User Gwern over on the ML scaling subreddit really digs into this whole serial regime idea. And let me tell you, it gets pretty wild, especially if you're deep in the weeds with AI engineering and research like we are.
100%. Gwern starts by laying out the current landscape. They say, and I'm quoting here, the current scaling regime seems to be heading towards something like 1 million plus GPU data center, doing moderately parallel stochastic gradient descent on enormous data sets to train enormous models, probably with the intention of doing LLM-based search over private data lakes for internal tooling or public-facing products.
So basically, everyone's building these massive GPU farms, all optimized for parallel tasks. Which, I mean, makes sense given the direction things have been going.
Right. But then Gwern throws this curveball. What if AI training doesn't need to get more parallel? What if it goes completely the other way and gets way more serial?
Okay, hold on. Before we go any further, can we define serial regime? What does that even look like when we're talking about AI training?
So Gwern lays out a few scenarios. One is, what if someone develops an optimizer that prioritizes how efficiently it uses each data point instead of just raw parallel power? Imagine squeezing so much learning from each data point that it's actually better to run them one by one or in tiny batches on one super powerful chip.
Instead of spreading the work across tons of GPUs,
hmm
you're saying it might be more efficient to have this one beast of a processor just crunching through the data sequentially.
Exactly. And it's not just optimizers. They even talk about a potential shift back to architectures that are better suited for serial processing. They even say, and I quote, one might even see something like RNNs or all that in a bag of chips yet again.
Interesting. For those who don't remember, RNNs, or recurrent neural networks, were kind of a big deal before transformers stole the show. They're naturally better with sequential data, but they haven't been as scalable. What would make them come back?
One reason is how RNNs work. They have all this back and forth communication between different parts of the model during training. That doesn't play as nicely with massive parallelism like transformers do.
So even with a million GPUs, if your architecture demands a more serial approach, you're not going to get the same gains. It's like trying to win a marathon with a team of sprinters. All that speed, but not the right kind.
Exactly. And to back this up even more, Guerin points to trends like grokking. They say another possible driver of a serial regime would be if training regimes shift to smaller batch sizes, as seems to be the trend already, or even single data points, as with grokking.
Grokking those moments where an AI model suddenly gets it after struggling.
Right. And the thing is, grokking tends to happen when you train on smaller data sets for longer. This hints that it's not just about data volume. It's the deep processing, the complex interactions within a model.
So not just algorithms, not just architectures, but the whole training philosophy could favor serial processing. Didn't Gorn also bring up active learning and data set distillation?
Yeah, they wrote, more speculatively, one might see breakthroughs in active learning or dataset distillation such that training datasets become radically smaller, and again, the advantage of enormous scale shrinks while the need for raw speed on a given model increases. So basically, if choosing the right data becomes super important, it's not about having mountains of data, but having a system that chews through and learns from smaller, curated datasets really fast.
Quality over quantity in the data department for this serial regime. Okay, I think I'm following how this shift could change algorithms, architectures, even our whole approach to data. But let's get real. What kind of hardware can actually handle a serial regime? What's powering this thing?
Now, this is where things get really interesting. Gwern says, what sort of hardware do you want in the serial regime? It would look a lot more like supercomputing than the mega GPU data center.
Supercomputing. So we're ditching the thousands of GPUs all wired together and going back to what? What would that even look like?
They mention high-end CPUs, maybe even overclocked to the max, though they admit that might be less likely.
CPUs. Seriously, I thought those were all for serious AI work.
They have been. GPUs have been king for the kind of parallel processing that's dominated deep learning. But remember, in a serial regime, speed is all about how fast you can run a single model's calculations one after another. That's where CPUs and their raw per-core speeds might have an edge.
So it's like back to the future for AI hardware.
Yeah.
Fascinating. But Guerin did say there's a more plausible hardware scenario, right?
Right. They write, more plausible is that it would continue to look mostly like current DL, but highly serial, like synthesizing a data point to train on immediately and discard, or training in a grokking-like fashion. Basically, picture this. A few powerful GPUs in one machine doing all the work, while a whole data center full of GPUs just sits idle.
Okay, so if CPUs aren't the answer and a massive GPU data center isn't ideal, what's the alternative?
This is where a company called Cerebras comes in.
Cerebras. Those are the folks making those monster AI chips, right? Practically the size of the pizza.
That's the one. Cerebras has gone all in on this idea of single massive chips that can outperform entire GPU clusters for certain tasks.
So they're really banking on serial processing as the future. What is it about their tech that makes them a good fit for this shift?
It's all in the chip design. Even when you link them up, traditional GPUs have this overhead, this lag when they have to share information. It's just part of how they're built, spreading data across multiple units.
More moving parts, more chances for bottlenecks.
Exactly. Cerebras eliminates that. Think about it. With a Cerebras chip, your entire model, all the billions, even trillions of parameters, live on one piece of silicon.
So no more data traffic jams. I'm starting to see why Guerin thinks they could be a big deal if this serial regime happens.
It's a compelling case. Guerin even points out how Cerebras themselves are claiming these huge per-iteration speedups compared to traditional CPU clusters.
How much faster are we talking?
They give this example, right? It's about solving linear systems, super common in AI. Cerebras was apparently over 200 times faster than a CPU cluster on this.
200 times.
Yeah.
It's not just faster, there's a whole different league of AI processing. But let's shift gears a bit and talk strategy. Even if Cerebras has the hardware, what does it mean for the big players, the hyperscalers? They've poured billions into their giant GPU setups. Are they really going to drop all that if the game changes?
That's the billion-dollar question, isn't it? Guerin even says, the serial regime is far from certain. I'd put 25% on it, in fact. But that's still enough to worry about given the stakes.
Yeah, a 1 in 4 chance of upending the entire AI hardware landscape is nothing to scoff at, especially if you've bet the farm on a certain approach.
Exactly. So what Guerin suggests is that these companies need to at least think about hedging their bets.
What would that even look like?
Well, Guerin lays out a few options, each with its own risks and rewards. First, they could invest directly in Cerebras, though with their current valuation, that's a tough sell. Like they say, outright buying Cerebras is probably too expensive right now, last valued at $4.
Yeah, even for companies with deep pockets, spending billions on something that might be the future is a hard sell.
Right, so Guerin proposes something a bit more strategic. Negotiating options on future Cerebras hardware. The idea is Cerebras might be undervaluing the serial regime, meaning they'd sell those options for less than they'd be worth if it happens.
Like an insurance policy for AI hardware. If the serial regime doesn't pan out, you're only out the options. But if it does, you're in the front row with early access to tech everyone wants.
Exactly. But then Guerin throws in this even more aggressive option.
Oh, I love a good aggressive option. Lay it on me.
They suggest hyperscalers buy Cerebras hardware now and basically try to force a breakthrough in the serial regime.
Now, that's putting your money where your mouth is. That's a high-risk, high-reward move for sure. What's the potential upside?
The payoff. Imagine if you cracked the code of the serial regime first. You'd have a massive head start, years ahead of the competition in training speed and efficiency. As Guerin puts it, if one's researchers crack the serial regime, then one can immediately invoke the options to more intensively R&D choke-off competition and begin negotiating an acquisition to monopolize the supply indefinitely.
Talk about a power move. Controlling the supply of the most in-demand AI hardware would be a game changer. But what's the other side of that coin? What if a company goes all in on Cerebras and someone else figures out the serial regime first?
Good point. And Guerin acknowledges that. They say if someone else cracks the serial regime, then one at least has some serial hardware, which may only be a small factor slower. So they're still ahead of anyone who didn't invest at all.
Right, they're still in the game, even if they're not leading the pack. And even if this serial regime never really takes off, wouldn't that investment in Cerebras still be worthwhile?
That's the other thing. Guerin writes, and if neither happens, well, most insurance never pays off. And your researchers may enjoy their shiny new toys, and perhaps there will be some other spin-off research which actually covers the cost of the chips, so you're hardly any worse off.
It almost sounds too good to be true. I can see why Gwern thinks this is worth thinking about, even if it does sound a little far-fetched.
It forces us to rethink everything we think we know about the future of AI hardware. And that's the point Grin's trying to make.
It's about challenging the assumption that bigger is always better. Maybe it's not about making what we already have bigger, but about exploring completely different paths. It's that old saying, right? We're so busy trying to build a faster horse, we don't even think about if there's a better way to get there.
It happens all the time, especially in a field that moves as fast as AI. But like Grin is saying, sometimes those big breakthroughs, those aha moments, they come from questioning everything we think we know.
So how do we break out of that faster horse mindset?
Hmm.
How do we even start to imagine these completely different approaches to AI hardware?
That's the million-dollar question, isn't it? I mean, if we could all predict these huge shifts, we'd all be backing the winning horse every time. But I think it starts with cultivating a certain way of thinking, being okay with exploring the unknown.
What does that look like? What does that kind of mindset mean in practice?
Well, first, you gotta have a healthy dose of skepticism. Don't just accept things the way they are, even if it seems like everyone else is. Ask yourself, what if everything we think we know about AI hardware is wrong? What if there's a totally different way to do this?
Channel your inner skeptic. Got it. What else?
Second thing, and this goes hand in hand with the first, be really, really curious about fields that aren't your main thing. Some of the coolest innovations come from mashing up ideas from totally different places.
Cross-pollination of ideas. You get people from different backgrounds, different ways of thinking, in a room together. Who knows what they'll come up with?
Exactly. And last but not least, don't underestimate the power of just messing around. Be willing to experiment, even if something sounds crazy at first. Think about it. Some of the biggest discoveries came from people who tried something everyone else thought was nuts.
Embrace the experiment. I like the sound of that. It's like Gwern's post is a call to action for everyone in AI.
Hmm.
Think bigger, bolder, and yeah, maybe even a little weirder about where AI hardware could go.
100%. And who knows, right? Maybe that next big breakthrough won't come from some giant company or research lab. Maybe it'll be someone tinkering in their garage, trying out an idea everyone else dismissed.
And that's an exciting thought. We've only scratched the surface of this whole serial regime thing. If your curiosity is piqued, and I bet it is, go check out Gwern's full Reddit post. We'll link it in the show notes.
And while you're at it, let us know what you think. Is a serial regime in AI really on the horizon? What other AI hardware shifts should we be keeping an eye on? We want to hear from you.
Until next time, keep exploring, keep questioning, and keep diving deep into the amazing world of AI.